Hello everyone and welcome to another episode of Supplementary Videos. My name is Kasanas. Guys, I just want to apologize right away. Everyone in my house is sick, including me. You can probably hear it in my voice. But my students really need these videos, so we're going to try and get them out today anyway. In the next couple of videos, we're going to be exploring Unity's physics engine. All right, let's get started. Okay, guys, so we're going to be exploring Unity's physics engines. And I say physics engines because Unity actually has two separate physics engines, a 2D and a 3D engine. Today, we're only going to kind of do an introduction to the physics engines. In fact, we're only going to really take a look at the 2D physics engine for now. Just know that any of the components that we explore within 2D space, there is something equivalent in 3D space that you can utilize as well. It's important to also note that the 2D and the 3D engines do not work together in any way. So if you have 2D components, they will not interact with any of the objects that have 3D components on them. Okay, so we're going to explore the 2D engine today, but before we actually start the 2D engine, what I want to do is I want to take a quick look at sprites, and I just want to take a look at sprites so we have something that helps us visualize what's happening on the screen. Okay, guys, so just know that if you are interested in creating assets within your game and you want to use some type of image in your game, you can utilize pretty much any type of file type that you like. Typically, we use PNGs within gaming. The PNG itself allows you to maintain an alpha, so you can adjust the background as you see fit. It'll automatically cut out your image based on the alpha that you've supplied. A couple things I'm going to mention right away, and this is something that I do. First of all, I have my sprites folder. I keep all of my sprites located within that folder. I also have another folder in here that's called Basic Sprites, and I include a Basic Sprites with every project. I always start right away with my new project. I put this Basic Sprites folder in there, and it just has a number of different sprites that I can use for rapid prototyping. So if I want to test something out really quickly, I can use these Basic Sprites, and I can kind of throw it in and do something with it. You don't have to do anything like that if you don't want to. I just like to do that so that I can, test things out really quickly. So let's take a look at a sprite. I've used this Nighthead previously, and that Nighthead we previously used in the UI videos. If I click on it right now, you can see that I have a texture type of sprite 2D and UI, meaning that this asset can be used either within the game space or on our UI like you saw previously. Below that, we have the sprite mode, which is single. We have the choice of single or multiple or polygon. We're not really going to discuss this in this video. Just know that if you brought in a compound image, so let's say you had multiple sprites that you wanted to use in your game, you can use the multiple mode, and that multiple mode will let you kind of slice up your image so that you have multiple assets available within one kind of one kind of image. But for now, we're just going to assume that everything is a single asset. So I'm just going to leave it as single. Oops, I clicked off of it. Sorry. Guys, as I mentioned, I'm not well, so I'm hoping these videos are going to be coherent. We're actually going to skip almost everything else down here. Maybe we'll just take a quick look at what pixels per unit means. Basically, pixels per unit means how many pixels are associated with one unit in Unity, 1 unit size. So right now the grid is based on 1 unit size. If I drag this into the scene, and if I wanted to add a sprite to the scene, I can either drag it in here, I could drop it in here, anything I want. If I drag it into the play space and I let it go, it's automatically going to show up wherever I let go. And if I drag it into the hierarchy like this, it'll automatically show up at the origin. So just something that you want to be aware of. If I want to delete it, I can simply click and say delete, and it goes away. Uh, you saw how big the head is right here, right now. What I'm going to do is I'm going to go in and I'm going to change how the actual object was brought in, this pixels per unit, how it was actually brought into Unity. And I'm going to change it to a value of 10. So instead of having 100 pixels across 1 unit, it's only going to have 10 pixels across 1 unit. And when I do so, and I save it, save, boom, you can see how much larger this asset actually becomes. And that's because now 10 pixels indicates 1 unit within Unity. All right, so it's kind of a method of stretching or scaling your object. I'm going to leave that at 100, which it is by default. Okay, so that is a sprite. It's relatively simple to use. If we take a look at the actual object that I've dragged into the scene now, Again, our sprite asset has a transform node. It's used to manipulate the location, just like everything else. It's used to manipulate the location, the rotation, and the scale of the object. By clicking on the little dots over here and I say reset, it's automatically going to reset all the values in here. So I've gone back to the origin location. You can see I've reset my position. So the transform node is like every other transform node. It allows me to place the object within the scene and do that kind of stuff. The only other component that our sprite asset has, our sprite object has right now, is this sprite renderer. And this is what's going to allow the sprite to show on the screen. That's basically what it's for. Right here we have the name, so we could actually get rid of this if we wanted to put something else in its place. We could get rid of that if we change out the sprite that's using. Below that we have the color, and again, just like we saw with the UI, this allows us to tint our object any way we wish. And of course, all of these things are available on through code as well. We'll talk about that in a bit. Below that we have the flip, and this is a symmetrical object, so it might be hard to see. Let's see if we see it all. If we see it at all. Okay, yeah, you know, we're seeing it right here in the little dots, so it's not symmetrical. I lied. If we flip this back and forth, all this is doing is actually flipping the sprite along the x-axis. If we do this one here, it's along the y-axis. So we're able to flip the object simply back and forth. Draw mode, like we talked about previously, there are a bunch of different options as far as draw mode is concerned. Simple, sliced, and tiled, just like with UI. You'll notice there's no fill associated with this one. What else is important here? Material itself. So depending on the material you've chosen, and we haven't discussed materials yet, depending on the material that you're utilizing, you either require lighting or you don't require lighting with whatever material you've created. In this particular case, it is by default using the sprite lit default. And that means it does require lighting. We do have a global light in the scene, which is going to allow us to light this particular object. If we chose a different type of material, an unlit material, we would not require any lighting within our scene. Depending on what you're doing within your game, if you're using lights, etc., you might want to change out the materials. We'll talk about that later on. For now, we're only exploring the idea of sprites, so we can explore the physics engines. Uh, Below that, we have the sorting order. This is actually kind of an important one as well. The sorting order, you can create different order. You can create different sorting layers, and basically a sorting layer tells the renderer what's being rendered on top of what. By placing things in a particular layer, right now the only one we have is the default layer, and we're going to leave it like that for now. By creating ourselves different layers, we can create different sorting patterns. Different things will be sorted differently. And below that, we have the order and layer. So in the actual sorting layer, how are we rendering this object? Again, we can put any value within here, with the lower values being the lower values being rendered first and the higher values being rendered last. So higher values will be rendered on top of lower valued order and layer objects. This is going to prevent, if you must keep really careful track of this, especially when you start to have a lot of different assets in your scene. Keeping track of that will make sure that we avoid what's called Z fighting. Z fighting is when the objects are trying to render on top of each other and it doesn't know which one to put on top, so you kind of get this like flickering back and forth. You've probably seen it in different games if they haven't gone through and appropriately set their order and layers. So make sure that you are keeping track of the order and layer. The things you want to be on top should have higher values than the things that you want to be on the bottom. So if you're rendering something on as a background object, you might want to have a low value. Your character, which is in midground, might have a medium mid value, maybe 10 or whatever you want. And then your foreground elements will have values higher than your midground layer. Again, if you're making a game and you're being very serious about it, you might want to start yourself some kind of spreadsheet that allows you to track the layers themselves. You'll have a range for characters, you'll have a range for backgrounds, you'll have a different range, and you'll want to make sure that the objects themselves fall within that range that you set inside of that spreadsheet. Okay, so I think that's all we got to talk about as far as sprites are concerned. We'll come back and we'll talk about it at a later date when we start to go more in depth into the sprites themselves. So let's now talk about the components that are available through the physics engine. Right now, if I hit play with this sprite in place, and I'm on play maximize, so if I hit play right now, all that's going to happen is this sprite is going to boop, stay in the middle of the screen, just sit there and do nothing. All right, it's falling within my camera view, and therefore it's being rendered on the screen. It doesn't do anything at all, it just sits there. What we want to do is we want to allow this object to interact with physics. We'll talk about physics settings in a little bit. For now, let's take a look at the components that are going to allow you to have this object do something with a physics engine. There's a way to allow our object to be identified as something that's going to interact with a physics engine. Let's take a look at that component. And remember, guys, there's both a 2D and a 3D version of all of the different physics components we talk about. So if I go to my add component and I scrub down, I can see right here I have the choice of physics 2D or physics. Because I'm working with the physics 2D engine for now, I'm going to use physics 2D. I'm going to click on it, and I've got a bunch of stuff here. We are not going to cover everything that's in here right now. We're only going to cover the kind of the three basic things that you're going to use to do most of the stuff for the next little while. We'll talk about versions of them, but we're going to we're only going to talk about a couple because there's so many different ones here. In a later video, we'll talk about a lot more of this stuff. So what we want to talk about today, the first thing we want to talk about today is the rigid body. You can either search for it in here and try and find your rigid body 2D right here, or you can start typing it up here in the search engine, the search box, excuse me. I'm just going to add it. So when I click on rigid body 2D, boom, right away we get ourselves this component that's showing up here beneath our sprite renderer. This rigid body 2D is something that indicates that this object is going to be able to be affected by forces within our scene. One of the forces that is immediately available based on the physics settings is gravity. So we have gravitational force that's automatically applied to our objects, and any object that has a rigid body will automatically be able to interact with that gravitational force. So watch what happens now if I hit play. Because I've added that rigid body and because there's gravitational force within the scene, as soon as I hit play, gravity kind of takes over, grabs this, and it says, oh, I found a rigid body, and it automatically applies that gravitational force to this object. That object is pulled downwards. We'll take a look at why it's pulled downwards later when we take a look at our physics settings. But for now, let's kind of explore the rigid body itself, this rigid body component itself. So at the very top here, we see it's called a rigid body 2D. That means that this particular object will only work with the 2D physics engine. If I try to have it interact with anything 3D, it won't work. Below that, we have our body type. And our body type has a couple of different options, dynamic, kinematic, and static. For now, we're going to just leave it as kinematic, or sorry, as dynamic. Know that dynamic means that it'll be affected by all the forces that you have within the scene. Kinematic basically means that the object will not be affected by other objects within the scene, but can have forces applied through code. And static means no forces will be applied. Okay, so the other thing we're going to take a look at here, material. There's something here, a different material. This is not the same material as we saw previously in the sprite render at the top. This is a physics material. And the physics material is is created to give it some kind of properties, physics properties. So for example, we could make this bouncier, or we could make it, have more friction, or whatever it is we want. We can go ahead and add a physics material. Again, we're not going to explore that in this particular video, but know that it's available. Below that, we have a bunch of things, but this is what I'm interested in, mass. So mass itself allows us to add mass to this object. By default, it comes in with a value of 1. Everything comes in with a value of 1. By adjusting the mass, the forces that you can add to a particular object will behave differently. If something has a higher mass, then you have to apply a higher amount of force in order to make it work the way you want it to work. Mass itself can be adjusted anyway. If two objects come together of equivalent mass, they will push on each other equally. If a larger, heavier massed object comes along and pushes on another one, the heavier object will actually be able to push the lighter object out of the way. Linear dampening. Linear dampening is used for slowing down an object as a force is applied to it. The linear force will be eroded over time. That's what dampening basically means. Angular dampening means that the rotational forces, the torque that's applied to something, will be dampened over time. So right now, with a linear damping of 0, when we apply a force to this object, it'll just continue moving. It will never have any kind of like friction associated with it. It'll never slow down. It'll just keep moving forever. But if we applied a linear dampening of some type to it, then as the force is applied, when the force is stopped being applied, then it will slow down over time based on how much linear dampening you have. Obviously, the more linear dampening you have, the more effect that the dampening effect will have after the force itself is no longer being applied. Angular force does come in with a small amount of angular dampening automatically, and what that's going to do is it's going to slow down rotation. So if I apply a torque to this object, a torque force to this object, and spinning. After a while, if left by itself, once the force is no longer being applied, the angular dampening will kick in and it will stop the object from rotating. Below that, we have gravity scale, and it comes with a default value of 1. This is on an individual basis. So overall, when we take a look at the physics settings, you're going to see that we can set our object to have, set our scene to have a particular amount of gravitational pull in some direction. By adjusting on the individual objects how much gravity is being applied, we can adjust how quickly or how slowly something falls. So if I put this at a value, I'm leaving it at 1 right now. If I hit play and we watch how quickly this thing falls, you'll see that it falls at that rate. If I change this value to, if I change my value instead of a value of 1, I change it to 0.1 instead, and I hit play, then gravity will have much less effect on the overall object. You can see now how slowly it's beginning to fall. Okay, so let's just put that back to 1 so it's acting normally for now. And obviously you're going to adjust this on an individual object basis to allow it to behave differently than other objects within the scene. We also have this collision detection here. We have discrete and continuous. This is going to be used later on when we actually bump into things, and how often it detects whether or not how we're bumping into things. If we have it as discrete, it happens at very particular times. Continuous means a continuous check of interaction. Sleeping mode, we have never sleep, start awake, and start asleep. Never sleep means just keep checking for interactions. Start awake means keep checking, and then after a while it kind of kicks off. And start asleep means don't start our interactions until we actually awaken this object. Okay, let's see what else is important within here. That's all I'm going to talk about for now. That's all we're really interested for right now. It's going to get us through what we're doing. Okay, so that's how the rigid body works. So you saw when I hit play, this object kind of just fell off the screen. And what I want to do is, let's say I wanted this object to be able to interact with something. I want to be able to bump into something. Well, let's try adding something to our scene. So I'm going to go in here. I'm going to go into my basic sprites that I've added, and I'm going to allow me to add something to the scene. I'm going to add this kind of little platform thing. Again, it's just a sprite renderer. I've just kind of dragged it and dropped it in the scene where I want it. Now I know this object, I don't want it to fall. I want this platform to stay solid, so I'm not going to add a rigid body to it. But if I hit play, once again, my character just kind of falls off the screen. So I need a component that's going to allow my objects to interact with each other. And we're going to explore 2 different options for this to occur. We're going to take a look at both colliders and the option of a trigger. So let's start off with the option of a collider. A collider allows multiple objects, any object with a collider, to bump into other objects with colliders. So let's start off by adding ourselves to our knight. We're going to add ourselves a brand new component. So I'm going to go down to add component. I'm going to click add component. I'm going to scrub down to physics 2D, and I'm going to look for colliders. Whoa, there's a bunch of them. Box collider, capsule collider, circle collider, composite collider, custom collider. Guys, I'm sorry, my voice is breaking and I'm frequently having these coughing fits and I have to keep starting these videos over. I'm really sorry if the editing's poor. Anyway, so circle collider. We're going to actually go with circle collider. And the reason why, we'd actually have the options to create a bunch of different types of colliders, some that actually fit precisely around our character as an example. Basically what we're going to be creating here is think of it like a hitbox. We're basically going to be creating a hitbox. Anywhere that our collider is, our object can interact with other objects that are affected by physics. So for now, instead of going through and kind of tracing this character out and making an exact collider, which I could do, it would increase the number of collisions that occur. It would increase the amount of processing that I have. So I'm just going to go with something that is as simple as I can, something that's pre-made. I'm going to go with a circle collider. The circle collider basically fits on this character. I'm going to zoom in here. Basically kind of fits the shape of this character. He's basically a circle. Now, if we take a look at this circle collider right here, this component right here, we have a number of different options on how we actually want to go through and adjust this particular collider. The collider itself can be a little more exact because right now you can see that I've kind of got this big space. It's going around the ears, so it's kind of got this best fit scenario. It's going around the ears, and I don't really want it to do that. Instead, I'd rather kind of have it closer to the shape of the character's head. If we take a look at what the options I have here, I have this ability for the radius to adjust the actual size of my collider. I can go in and I can adjust it so it's a better fit to our character. I'm missing out on some of the interaction that's around here, but I don't really care, right? A radius like this works a lot better for me. Um, and if I haven't mentioned it yet, you could also do, I haven't, not in this iteration of this video anyway, of this part of the video, you could utilize this edit collider button right here. With the edit collider button on, instead of adjusting the radius, I can actually kind of pull this to a little more exact standard. So if I wanted to, I could, pull this out a little bit in a slightly different shape. Let's say I like that. Let's say, okay, I'm willing to have this kind of little bit of interaction down here. Uh, that's probably the best one. It was probably best the way it was, but you can see that I've kind of got more of an oval shape now. So I can use this edit collider button to do a little more precise editing. You'll see that I had little handles. Hopefully you could see I had little handles that I can kind of pull on and jerk around there that would allow me to adjust this collider to the shape I wanted it. So that's a pretty good fit. It's kind of allowing me to interact with this character around its head. Basically look at this as a hitbox. So a couple things as well to consider. I've got a couple of options here. I've got another material here, this physics material. And the physics material is not the same as the material we talked about previously. It's not the same as this physics material, or can be, actually it is, but it's not the same as the sprite render material that we talked about previously. Instead, it's just basically a material that allows us to have an interaction of some kind. It allows us to create bounciness, etc. I probably already said this as well. I really do apologize for these videos this time, guys. All right, so let's go down here and take a look at what's the difference about this one. We do have this is trigger, and we're going to talk about that in 1 second. So right now, I do have a collider on this object, and I do want to be able to collide with this object down here. That means that this object, my platform, also requires a collider. So any objects that we want to be able to interact is going to have a collider on it. I'm going to go add components. I'm going to go back down to physics, and I can find the collider I like. Oh, box collider is going to fit this pretty darn well. So I can kind of leave it as it is right here. It's pretty good as far as the shape is concerned. All right, let's zoom out here, and now let's see what happens when I hit play. Now my object, boom, goes in and rests on top of that platform. Obviously, this collider is not set up exactly the way it should. I should have shrunk this down to allow it to get together a little closer. Let's actually take a look at why. I'm going to turn off play maximize. I'm going to go to play focused. I'm going to hit play, and we'll take a look at why these colliders didn't come together closer. So there we go. In space here, it looks like they're pretty darn close. It doesn't look as close in here. It looks like there's a big enough gap in here. So what I might want to do, and I'm going to do this in real time. It's not going to save the effect. I'm going to click on my platform. I'm going to scrub down here to my box collider. I'm going to turn on the editor, and I'm just going to edit this and watch. You can see that as I adjust it, I can adjust how that object is sitting on top of that platform. If I want it to be closer, I absolutely could do that. I'm adjusting it there. There we go. That's a better shape. When I hit stop, and this is something important, when I hit stop and I'm no longer playing, boom, this went right back to its original settings. So this is something you should be aware of. Any adjustments you make in play mode will automatically be reset. So any adjustments I made there in play mode, you can see automatically reset. I have to go in afterwards and say, oh, I wanted to keep that. So I'm going to go in and adjust this when I'm outside of play mode and say, okay, yeah, now, oops, I grabbed the wrong thing. Now I like the way this is looking, and that's a little better. That's basically what you have to do. All right, so that is the collider component. A couple of things to take note. Right now, my platform itself, let's turn off our edit here. My platform itself was flat. This object hit the platform and it just stayed put. It didn't move in any way. If I'd had this at an angle, so let's go in here and adjust our rotation. So let's rotate it around our, where's our rotation tool? Right here. Let's rotate it around our axes, our Z axes. And I'm going to give this a little slant like this. Let's put this back on maximized. I guess I didn't have to. Let's put it back on play focused and zoom out here so we can see what's happening. Watch what happens now if I grab this knight head, move it up, and I hit play. Because of the way the physics engine works, it's going to grab and it's going to allow it to roll down that platform on the angle. When I had it flat, it stayed still. When I have it on an angle, it's going to allow this object to roll. So a couple things to be aware of. Depending on the type of collider you have here, this will roll at a different rate. If I had something with a flat bottom here, it might have hit and stuck and slid down much slower. Based on our physics material that we could have added to these objects on my collider here, I could have had on the collider on my platform, I could have had a high friction physics material that would allow this thing to slide down much slower or even just stick. So depending on what we're adding as far as those physics materials are concerned, which we'll talk about at a later date, and the type of collider I choose, we're going to have different interactions based on those two topics. All right, there's one more thing I want to talk about today, and that is the idea of the trigger. A trigger object is created using that little checkbox we saw previously. So if I select my platform right here as an example, and I look at my box collider, I can see I have is trigger as a checkbox available to me right here. The is trigger option will change how these objects interact. By setting something up as a trigger, it still allows a communication to occur between the two objects that are colliding. However, the trigger object will no longer be substantial, meaning that it will no longer stop an object from passing through it. It does detect when a physics object with another collider is passing through, and as long as one of the two objects has a rigid body associated with it, it will allow us to interact with these objects through code. So you might use a trigger object. And let me just show you before I actually tell you what you'll use it for. I'm going to turn this on, is trigger. So that's all you have to do to make this into a trigger. This is now a trigger. If I hit play now, watch what happens to my head. The head falls right through our object. It passes right through as if it's not there. And you might be like, well, why would you want to use that? You might use a trigger for something like a checkpoint where you want your objects to pass through. You want to know if your objects are passing through a particular location within space, allowing them to enter into that location space, turns on a save point or turns on a checkpoint or lets the object know that you're close enough to have an interaction occur or a number of different things. It can be used for a number of different things. Just know that as long as there's an object either with a collider or two triggers, as long as one of the objects within that interaction has a rigid body, we can actually access that information through code and do something when it occurs. We're going to take a look at coding with our physics objects in the next video. Okay, there's one last thing we're going to talk about right now, I think, today in this particular video, and that is the idea of our physics settings. The physics settings allow you to go through and set up how the majority of the interactions will take place by default. Again, as I've already mentioned, we can adjust individual objects based on the gravitational settings, for example, but overall, our objects will be affected by the physics settings we have set up. If we take a look at our physics settings, we can find them under Edit, under Project Settings, so Project Settings right here. Afterwards, oh, this is kind of squished. Let's unsquish this. Afterwards, what we're looking for is our physics settings. So scrub through, look for it until you find physics. We have the option for physics here, and we have the for the settings right here, and we have the options for our physics 2D right here. As I've already mentioned, these are two completely different physics engines. Okay, let's take a look at some of the options we have here. Notice the difference between the two. In our physics settings, we have three settings available to us: our X, Y, and Z. So we can apply force of gravity in any of the three directions. With our physics 2D, we only have our X and Y components, meaning we cannot apply gravitational force within the Z direction. By default, it comes in at negative 9.81 meters per second. Even though it looks like it's falling really slowly when we actually hit play, we can adjust this and it can be moved in any direction we want. So let's say we wanted to instead say, no, I actually don't want any interaction within the Y direction. I only want to have my gravitational force be applied in the X direction. Let me put it at a value of 10 right here. So I'm going to positive 10 exit. Once this is all set, I'm going to move this out of the way for now, and I'm going to hit play and watch what happens. Boop. There we go. Our force is now being applied in a completely brand new direction. Okay, awesome. Let's drag this back in. So that shows that we can kind of change these forces to act in any way we want to. I'm going to put this back to negative 9.81. But what I like to do oftentimes for gravity, especially if I'm making something like a platformer, I would like to go through and usually set this to a higher value. I normally set it somewhere around negative 30. So let me just show you what it looks like. So I normally set somewhere around negative 30, depending, of course, on the type of game you want. I find that with a value of negative 30 for my gravitational pull, the gravitational force, it actually moves at a much higher rate. So you can see how much faster it goes there. And I like that better as far as my jumps are concerned. Whenever it jumps and it's being pulled down, I like that a lot better. There's a ton of stuff that you can actually take a look at in here. All of this stuff here will be applied as your default settings. So you can see that, for example, there's a default physics material here. We'll talk about physics material in an upcoming video. I think today, just maybe in a third video. All right, so there's a bunch of different settings that you can set up in here. We're not going to go over these for now, but you can play with these, and really this is just setting your default state for a lot of things. All right, guys, that's going to take us to the end of this particular video. I'm not going to go on with this. I'm going to go on to the idea of coding in our physics, our interactions. We'll go take a look at adding code so that our physics interactions actually do something. All right, guys, I hope you enjoyed this video. If you did, let me know down below with a thumbs up. If you didn't, I'm sorry, I'm really sick. But like I said, I really need to get these out. I apologize. I'm sure these are going to be edited fairly poorly. My voice is cracking and I've had a lot of coughing fits during this recording. And I do apologize, guys. So hopefully you stuck with me and you still liked it. All right. Thumbs up, thumbs down, comments down below. And if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.